Alright, welcome back, Algebra 2. Example 1, we're going to estimate the real 12th roots of 2, because if you remember from our last video, we ultimately wanted to find the ratio here of the piano keys. So we had r of 12 equals 2, or 2 equals r of 12. Same difference here. So essentially, in order to do that, this means what number times itself 12 times will give me exactly 2. And as we know, there's probably not an exact number that's going to work for us here. So let's go ahead and grab our calculators here, and I'll show you how to do these. If you want to do the 12th root of 2, there's actually 2 separate ways you can do this. We're going to learn a little bit more about rational roots in the next couple of sections here. But in order to do this, you could put in the number 12, and then go to your math menu here, which is where you find MathFrac, which we all know and love. But if you look at this 5th option down here, it says x. This little x here means take the whatever root of whatever's coming next. So what it does is, if we choose that one, it takes whatever's before it, and it's saying take the 12th root of whatever I'm going to put next. Well, we want the 12th root of 2, so we're going to put a 2 here. Okay, so essentially what we're doing, and maybe I should write this over here, is to cancel out this 12th power, we would have to take the 12th root. Much like we would cancel out a squared power, we take the square root. We just normally don't write the 2 here because that's your most basic root. So of course what I do to the left-hand side, I have to do to the right over here. So we'd say the 12th root of 2, and that's what we're doing here. So on this side, you know, the squares and square roots cancel each other out, or the 12ths and 12th roots cancel each other out. So we're just left with r over here. And then we have to find whatever the 12th root of 2 is. And so let's hit enter, and you know it's going to be a decimal, which we expected, so it's going to be 1.05, let's say 1.059 will be good for our purposes. So that's your 12th root of 2. So, as you can tell here, your even powers though, remember every time you take your square root, you have to have your plus minus. So even powers will always have a plus minus on them. So we actually have the plus 1.059 and the minus 1.059. So there you have it. Okay, so it says to find the frequency of middle C if the A below middle C is tuned to 220 Hertz. Alrighty, so now what we have to do is, well, we have to go back and look at our keyboard. So we want to find middle C. So we have to figure out how far that is above the A that's below it. So let's go back to our keyboard here. This is where we're starting. We want to get to middle C. How many notes away is that? So we would have 1, 2, 3. So essentially we're finding F of 3 using our new R that we have here. So let's go back over here. So we're finding F of 3. Using our formula, which was f of 0 then times r, but we now know what r is. We just found it in the last example. R was 1.059, so let's put that in instead. 1.059 and then to the 3rd power. Now this is silly. I probably should have plugged in here that our initial key was tuned to 220 Hertz, so that's our initial f of 0, so probably should have put that in here. So f of 3 equals 220 times 1.059 to the 3rd power. And now we can find f of 3. We just have to evaluate what this is here. So we would have to go to our calculator and find 1.059 to the 3rd power, so let's do that. Oh, look, there it is. So let's just take that to the 3rd power and multiply by 220. And we get f of 3 here is going to be 261.63. And then remember our unit here, oh sorry, it's an awful 3, there we go. Our unit here is Hertz. So we'll always want to put units on our word problem. Get rid of this guy. So there you go. Your middle C is tuned to 261.63 Hertz. Alrighty, our next theorem is your 1 over n exponent theorem. So it says when x is greater than or equal to 0 and n is an integer greater than 1, we say 1 over x to the nth power is the nth root of x. Okay, so go ahead and jot that down. I'll explain it in a little further detail here when we see our next example. Okay, so we're going to evaluate the following. So essentially, what that last theorem was saying was if I have 1 over whatever number here, this is like saying take the 4th root of 81. So I could rewrite this if I really wanted to. I could rewrite this as the 4th root, just like I did with the 12th root earlier, of 81. So I could have this written this way, or I could have it written with the power as rational power, which is fine. I could do it either way. So this is saying take the 4th root of 81, so is this. So I could do it either way on my calculator. So let's do it the original way I showed you, using this little symbol in here. So we put in our 4 first, and then we go to our math menu, and we go down to 5, and we pull this. So this is saying take the 4th root of what I'm going to put in next, so the 4th root of 81, and you hit enter, and boom, that's 3. So there you go. So you would say that answer here is 3. Now the other way you could actually evaluate this, and you should get the very same answer, is you could literally put it in your calculator this way. So you would put in 81 first, so 81 to the 1/4 power. And you have to be very, very careful here, because if you do it like this, to the 1/4 power, it can't handle that. You need to say 81 to the, and then put parentheses. Remember I said fractions always go in parentheses for best practice here. So 81 to the 1/4 power, we should get this answer of 3 because we already know the answer is 3. So if I put parentheses in there, I get the right answer of 3. So now you can evaluate it in your calculator doing the old school way, or you can use your rational powers and do it this way here. Okay, so let's try this next one, and we're actually going to do this the new way. And I want you to be careful here because you might be thinking, oh, that's the square root because I have 1 over 2 here, so square root. I cannot take the square root of a negative number. Or I can, or maybe I is going to be involved here. But this is actually not the case. This is taking the square root of just whatever's next to it, the 4. This negative 1 is hanging out by itself. So if I were to rewrite this properly, I suppose, we'd have negative 1 and then times 4 to the 1/2 power, and 4 is the only thing being taken to the 1/2 power. Okay, this negative is kind of by itself. I know it's weird to think that way, but there's no parentheses around here telling me to take the whole thing to the 1/2 power. So that's not exactly what I want going on here. So we want to take them separately and then go from there. So we're going to take 4 to the 1/2 power, which we don't even need our calculator for. That, what's the square root of 4? Well, that's 2. So then we have negative 1 times 2 here, which is pretty easy to do, and that's going to be negative 2. And there's our answer, negative 2. Okay. So rational powers sometimes are a little bit easier to work with because it's weird to look at things like this. We like them better as to the powers. I know it's weird to see a fraction there, but that's all that means. Alrighty, our next theorem. If we think about the graphs that they produce, these are the same graphs we saw back a couple sections ago, where we had either parabolas for even numbered things. See, x is even here, or excuse me, n is even, the power is even here, and then we had our little S curve for when n was odd. Okay, so when we had an odd power. Okay, so we had these two different graphs. So now we're going to actually take a look at what solutions they give you. So roots and solutions are synonymous. They're the same thing. So let's take a look at when I have a positive real number, what kind of roots we're going to have. So when I have an even graph, so let's look at this situation first. When n is even, well, we know when n is even, we're in this graph over here. So I'll just maybe write even a little bigger so we can easily tell. Alright, so even here. That means I'm going to have a positive number, which means I got to be up here, okay, in the positives. And what happens is this line indicates, well, how many times does it hit our graph? Well, it hits twice, right here and right here. So that means how many solutions am I going to have? Well, there's going to be 2 because we have 2 points of intersection. That means any positive real number is going to have 2 roots when n is even. such as when I take the square root or the fourth root or the sixth root or the eighth root or so on and so forth. Okay. When I have n still being positive here, so we're still positive. When n is odd, however, so we're moving over to the other graph over here, so we have an odd root, so like we're taking the third root or fifth root or sixth root, etc., etc. When I have a positive number, well, look at here, we have our positive line up here. This is above the x-axis. Well, how many times does it hit our graph? Only one time. So we're only going to have one root at this case. Okay, only one root here. All right, now when I'm speaking about negative numbers, so now we're jumping down to the bottom of our graph here in the negatives. When I have n being even, well, let's think about this. If I have an even graph, if I'm in the negatives anywhere in the negatives, do I ever hit my graph? No, there's no points of intersection, meaning we're not going to have any real roots. So if you have a negative number, which makes sense, because if I try to take, say, for instance, the square root of negative 4, well, we know there's no real roots. We know we'd have to have an I involved. So, therefore, there's no real roots. We only care about the real roots here. We're done with I for now. It'll come back, but just for the moment here. Okay, so no real roots. All right, now when we're talking k and negative being the odd over here, so one real root is what we should expect. Well, does it hit one spot? It's exactly in one spot. So if I have an nth root when n is odd, so let's say we're taking the cube root, we're allowed to have solutions here, because I could have a negative times a negative times a negative, still give me a negative. The reason that works is because it's an odd number. If you have an odd number of negatives, your solution is going to be negative. Alright, so let's take a look at example 4. We're going to find all real solutions to 3x to the fourth power equals 240. So this first equation here, you want to get x by itself, so you might be thinking, oh, let's take the fourth root, which we will, but hold on, we can't do that quite yet. We have to have the fourth power stuff by itself, which is just the x part right now. So this 3 is not being taken to the fourth power, so we need to get that 3 out of there. So since this is 3 times x to the fourth power, we need to get rid of the 3 by dividing on each side by 3. And therefore we would have x to the fourth power. 240 divided by 3, well, 24 divided by 3 is 8, so that would be 80 over here. And then when you actually take the fourth power, now you could square root and put a little 4 out there, but I want you to get in the habit of using our rational exponents, because that's what we have coming next. So we want to take this to the 1/4 power, would be just like taking the fourth root. So the 1/4 power over here, and then the 1/4 power over here, because of course what we do to the left side, we have to do to the right. So what happens over here is these cancel each other out, and I'm just left with x. Since they're reciprocals, they cancel each other out. So then you have x, and then 80 to the 1/4 power, which we have to get our calculators here. Give me 1 second. Alrighty, so let's go in here, and 80 to the 1/4 power. Oh, we did 81 to the 1/4 power, which gave us 3, so that's not quite where we want to be. We want 80 to the 1/4 power. Remember, you have to put those in parentheses. We hit enter. Oh, well, it makes sense. It's very close to 3. So it's 2.99 is our answer. 2.99. And now you have to remember, though, we took an even power. So it's not just 2.99, but it's also the negative of 2.99. So we have plus or minus that should be hanging out front here. So since it's even, that's why we can take that and say it's plus or minus. If it was the 1/3 power, it would just be the positive. Okay. Alrighty, down here. So we want to have, we already have, excuse me, x to the 1/2 power equals 3. So in order to get rid of this, x is already by itself, so we're just going to multiply everything, or excuse me, not multiply, but we're going to take it to the second power to get these to cancel. So of course what I do to the left side, I have to do to the right side over here. So we're taking everything to the second power. And so these cancel, and we have x equals 3 squared. Well, that's easy, that's 9. And you might be thinking, oh, we need plus or minus 9. We just squared 3. We didn't square root 3, so you have to be careful with that here. So when you square it, it's just 3 squared, which gives you 9. That's it. Alright, and we have one more example here. Example 5 says, show that 2, -2, 2i, and -2i are fourth roots of 16. So I'm actually just going to do 2 for you guys, and then I'm going to have you guys do the other ones in the exact same way to finish this up for tomorrow, so that I'll check all your answers tomorrow. So essentially, if you want to show that 2 is a fourth root of 16, that would mean 2 times itself 4 times should give you 16. So, well, let's see what we get. So 2 times 2 is 4 times 2 is 8 times 2, oh, that is 16.